Raw food often tastes profoundly different from its cooked counterpart, a chemical magic trick performed by heat. Hundreds of new flavor molecules spontaneously generate during cooking, entirely transforming ingredients into culinary masterpieces. You might perceive cooking as a simple process of applying heat, softening ingredients, or ensuring food safety. Your kitchen actually operates as a sophisticated chemical laboratory, orchestrating profound, invisible molecular transformations. Every sizzle, bubble, and aroma signifies a complex chemical reaction taking place right before your eyes. These fundamental chemical switches dictate how food tastes, smells, feels, and ultimately satisfies your palate. Understanding these changes empowers you to master flavors and textures, elevating simple meals into extraordinary experiences. It's about far more than just following a recipe. It's about actively manipulating molecular structures with intent. This hidden world of culinary chemistry unlocks secrets to perfect browning, incredible aromas, and rich, deep flavors. Chefs worldwide leverage this scientific knowledge, pushing boundaries of taste and creating iconic dishes. From a humble vegetable to a succulent steak, every ingredient holds a universe of untapped chemical potential. Prepare to discover the astonishing science behind why your favorite dishes taste so incredibly delicious. One of the most critical switches is called the Maillard reaction, responsible for countless beloved cooking aromas. This complex chemical cascade occurs when amino acids and reducing sugars react under heat, typically above 285 degrees Fahrenheit. Imagine tiny sugar molecules and protein building blocks dancing together, forming entirely new, flavorful compounds. It creates that irresistible golden brown crust on seared steaks, roasted potatoes, and crispy fried onions. Without the Maillard reaction, your toast would remain pale bread, and your coffee beans would lack their complex depth. Hundreds of distinct flavor molecules emerge from this reaction, contributing to the savory, nutty, and roasted notes we crave. But here's the fascinating part. The specific compounds produced depend entirely on the exact amino acids and sugars involved. That's why beef develops different Maillard flavors compared to roasted chicken or baked goods, even at similar temperatures. Cooks can accelerate this reaction by increasing surface area, like patting meat dry, or by adding a pinch of baking soda. Baking soda subtly raises the surface pH, encouraging the amino acids and sugars to react even more vigorously. Wait until you hear how this reaction transforms humble ingredients into something truly extraordinary and unforgettable. Consider how deeply roasted vegetables achieve their caramelized sweetness and nutty notes through this very process. The rich aroma of freshly baked bread or a perfectly seared scallop owes its magic entirely to Maillard's intricate dance. Even the complex flavors in dark beer and chocolate develop significantly due to this fundamental browning reaction. Controlling the Maillard reaction is a chef's secret weapon for building layers of intense, satisfying flavor in any dish. Another dramatic switch involves proteins, which fundamentally change shape when exposed to sufficient heat or acid. Proteins are long, folded chains of amino acids, much like intricately coiled telephone cords. When you apply heat, these delicate coils unwind and rearrange, a process called denaturation. Think of cooking an egg. The clear, runny albumin transforms into an opaque, solid white mass. That transformation is protein denaturation in action, with the uncoiled proteins forming new, solid structures. Similarly, cooking meat unravels its muscle proteins, making the texture tender and easier to chew. The color change from red to brown in meat also reflects these protein transformations as myoglobin denatures. Acid can also trigger this switch, as seen in ceviche where lime juice cooks seafood without any heat at all. The acid denatures the fish proteins, firming the flesh and turning it opaque, mimicking the effects of heat. This reveals an astonishing principle. Chemical environment can be just as powerful as temperature in changing food. But there's a fine line. Overcooking denatures proteins too much, squeezing out moisture and making food tough. Distinct from Maillard, caramelization occurs when sugars alone are heated past their melting point, typically above 320 degrees Fahrenheit. This process breaks down sugar molecules into various complex compounds, creating nutty, buttery, and slightly bitter notes. Imagine making caramel sauce. The sugar crystals melt, bubble, and then magically transform into a rich, amber liquid. It's a pure sugar transformation. Unlike Maillard, which requires both sugars and amino acids interacting simultaneously. Baking soda provides another fascinating chemical switch in the kitchen, acting as a leavening agent. When combined with an acid and liquid, baking soda produces carbon dioxide gas, creating bubbles that make cakes rise. This simple acid-base reaction demonstrates how precise chemical balances are crucial for achieving desired textures. Even something as subtle as adding salt can fundamentally alter food, drawing out moisture or enhancing sweetness. Each ingredient possesses unique chemical characteristics, enabling a vast array of potential switches during preparation. These molecular transformations are not just theoretical, they are the very essence of deliciousness you experience daily. Understanding these fundamental shifts transforms you from a mere recipe follower into a true culinary alchemist. And that's not the strangest part. These reactions are happening constantly, in every kitchen, all around the world. What else could be hiding within our everyday ingredients, just waiting for the right chemical trigger to emerge?
The possibilities for flavor creation become truly endless once you grasp these underlying scientific principles and applications.
Recognizing these chemical switches profoundly changes how you approach cooking and recipe development. You gain the power to intentionally manipulate flavors, textures, and aromas rather than simply hoping for the best. Imagine adjusting cooking times or ingredients to perfect that golden crust or achieve ideal meat tenderness every time. This scientific insight explains why certain ingredient pairings work synergistically and others simply clash. It reveals the science behind why a splash of acid brightens a dish or why salt enhances sweetness. Home cooks can elevate their meals from good to extraordinary by applying these simple, yet powerful chemical principles. Chefs constantly innovate by pushing the boundaries of these reactions, creating novel dishes and unexpected flavor profiles. This knowledge allows for precise control, ensuring consistent quality, and enabling truly remarkable culinary achievements. This emulsions like profound mayonnaise to perfectly scientific proofing bread, one endeavor. It transforms cooking from a collection of steps into an artistic and scientific exploration of edible potential. Understanding this underlying chemistry provides a deeper appreciation for every bite you take and every meal you prepare. Truly master the art of chemistry guides cooking, one endeavor chemical switch at a time. Ultimately, every delicious meal is a testament to the incredible chemical transformations happening right in your kitchen. Food science and cooking chemistry are not separate disciplines, but intertwined forces shaping our culinary world. Embrace these hidden reactions, and you will unlock a universe of flavor, texture, and aroma in your own cooking. If you want to explore more fascinating scientific insights that redefine your everyday experiences, then you know what to do. Hit that subscribe button for more mind-blowing facts, and join our journey of discovery and learning. Let us know in the comments which chemical kitchen switch you find most surprising or useful in your own cooking.